Alright, this is chemistry video 11.2c, the combined gas law. So basically in this video we're just going to be looking at some problems using the combined gas law. Alright, so combined gas law is just simply a combination of Boyle's law and Charles's law. So if you understood those two very well, which you need to in order to do this, this shouldn't really be anything necessarily more difficult. I'm just going to combine the two ideas. So the problem we're going to be looking at in this time is where Boyle's law just looked at pressure and volume, and Charles's law looked at temperature and volume. This is going to combine all these ideas, so we're going to be tweaking temperature, volume, pressure, all in one problem. Okay, so one concept that we need to understand for this is this idea of STP. Okay, STP stands for standard temperature and pressure. Okay, and standard temperature and pressure is 1 atm and 273 kelvins, or I suppose 0 degrees Celsius would be the equivalent. Okay, and this is something we need to know and remember, memorize, whatever, because frequently in problems from here on out, something will refer to STP, standard temperature and pressure. So you need to know what those values are. Okay. All right, so let's look at how this works. Let's look at a problem. So in this example, I have a 154 milliliter sample, carbon dioxide gas, which is generated by burning graphite and oxygen. That's not necessarily important or critical to this problem, but basically what we need to know is I have this 154 milliliter sample. Okay, the pressure generated, the pressure of this generated gas is 121 kPa. Okay, temperature is 117 degrees Celsius. I need to know what volume will the gas occupy at STP, at standard temperature and pressure. So it's helpful for these problems to kind of write down everything we know and then write down what's happening. So I'm starting with this 154 milliliter sample. Okay. My starting pressure is 121 kPa. My starting temperature is 117 degrees Celsius. Okay, and then I'm going to change my pressure to standard pressure. Well, on the previous slide we said standard pressure, okay, was 1 atm. Okay, well, what's the equivalent in kPa? Because this is given in kPa and kilopascals, not atm. So you need to go back and remember that 1 atm was equivalent to 101.3 kPa. So I'm going from a pressure of 121 to 101. Okay, and then standard temperature in degrees Celsius is 0 degrees Celsius. So I have this volume, I'm decreasing the pressure, I'm decreasing the temperature. So I have to figure out what that's going to do to my new volume. Okay, so once I write down all my knowns, okay, all the information I have, and understand what's happening, it's really important to think about, okay, what's happening, sort out all these words and actually write down the critical information. Okay, the next thing you should do is convert all Celsius units to kelvins. Remember, all of these problems we need to deal with Kelvin. We need to do with kelvins. Okay, so I need to convert both of these to kelvins. So the 117 degrees Celsius, of course, to convert to kelvins, I add 273. Okay, so this is 390 kelvins. Okay, and my 0 degrees Celsius, when I add 273, will be 273 Kelvin. Okay, so now my units are good. So again, I'm changing my pressure from 121 to 101. I'm changing my temperature from 390 to 273. All right, so my next step is to set up my ratios that I'm going to multiply by. So I'm always going to begin, just like the Boyle's Law and Charles' Law problems, with the value that I'm trying to sort of figure out. Okay, I'm trying to figure out what my new volume is going to be. I'm given an old volume, so I'm going to start with that. So 154 milliliters. Okay, so the first thing I'm going to look at is this change in pressure. Okay, so my pressure is going from 121 kPa to 101.3 kPa. So if my pressure goes down, okay, we need to think about what's going to happen to my volume. Okay, so according to Boyle's law, pressure goes down, volume should go up. So if this was the only change that happened, my volume would go up. So if I want, when I'm multiplying 154 times this ratio, okay, and I want the 154 to end up bigger because Boyle's law says that my volume should go up, I need to put the 121 on top. The 101.3 on the bottom. Okay, so this ratio right here handles my change in pressure. All right, now I need to deal with the change in temperature. So in this example, I'm going from 390 kelvins to 273 kelvins. So my temperature is going down. So according to Charles's law, if my temperature goes down, my volume will go down. Okay, my volume will go down. So if I was ignoring this middle section ratio here, and I wanted this 154 to go down because of my change in temperature, I put the small number on top, 273 over 390. Okay. So again, I'm dealing with these things independently. I first look at my change in pressure, ask myself, what is that going to do? If I change my pressure from 121 to 103, my pressure is going down. That should make my volume go up. So I set up that ratio accordingly so that the 154 goes up. Then I look at temperature. My temperature in this case is going down. If my temperature goes down, my volume should go down. So I set up this ratio so that the volume would go down. Okay, just to kind of check, make sure the units are the way I want them. I'm trying to end up with volume. The kPa unit will cancel out here, here. Kelvins will cancel out here and here. So I'll end up with a unit in milliliters. So the math on this, you know, you can, depending on how you use your calculator and what kind of calculator you have. You know, some are better equipped at handling many operations, but I would just say to be safe, you know, you want to kind of break it down a little bit, depending on, until you get the hang of how your calculator handles all this stuff. So basically we're doing 154 times 121 times 273. We're dividing all that stuff by 101.3 times 390. Okay, and so if you do all this correctly in your calculator, it comes out to roughly 129 milliliters. And that's it. That's the combined gas law.